Hello, everyone, and welcome to week 4 of algebra class. This time we're going to be doing 3.2, understanding relations and functions. Uh, some vocabulary you need to know beforehand. The word relation here is one of the vocabulary words that you're going to see. It's a set of ordering pairs, x and y. It's also known as a coordinate point. That's a very basic definition. We're going to go into a little bit more of what a relation is, because throughout this lesson you're going to be proving if if certain sets of relations are actually functions or not, and what that means. But in order for you to do that, you need to just a reminder of what certain vocabulary is. Domain is all possible inputs of a relation, aka all possible x values in a data set. So if you're given a bunch of essentially coordinate points for a graph, right? The x values are all your domains. So if you have a bunch of coordinate points, you want to take a look at all the x values. Let's say you're given like, this is a coordinate point, right? The x always goes first and the y always goes second. Let's say you're given 3, 2, 5, 7, 8, and 9. If I were to ask you, hey, give me the domain of this function, right? Of these coordinate points. The domain is just asking you for the x values. It's just asking you for these. And you would list them. You would say domain. And then this symbol right here it just means a set, like a data set. So I would order them from least to greatest. So it would be 3, 5, and 8. Right? That's my domain. My range, if you remember from last week, it's all possible outputs of a relation, aka all possible y values. The x's go into a function and the y's is what come out. Y is basically your answer. It's the result, right? But if we're looking at just the coordinate points, these are your y values, or they're your range. So if I ask you, okay, you got the domain, you've given me the domain, how do I find the range? What are my range of my functions, right? You can just list them: 2, 7, 9. So what happens if in your data set, in your relations, you end up getting a number that's repeated, right? So let's say I have another coordinate point, right? And let's say I have like another 3, but this time I have 7, right? Um, oh, that's a bad example. Let's have 17 then, right? So how does this change my domain and range? Well, if you notice, domain, we already have 3 here. We only have to write it once. If the number's repeated, you don't necessarily have to write it again. You can just leave it the way it is. However, 17, right? It's kind of new. So we would have to include it. Okay, that is our updated range. So if you notice, there's 4 ranges, but there's only 3 domains. That's because the 3 is repeated twice. Okay, so this is going to be important for what we're going to be talking about next. All right, so in these problems, you're going to be asked about relations, and you're going to be asked, okay, these are your coordinate points, these are your ages, these are whatever it is that they're going to ask you, and you're going to have to do 3 things, right? You're going to have to do step 1, step 2, and step 3. Step 1 is making a table, right? So let's read what the problem says. The problem says, for the following relation, the x input is in ages of the boys, and the y output is their corresponding heights. So the inputs and the outputs are given to us in the form of coordinate points: 741, 845, 949, 1052, 1053, 1155, and 1259. So our first step, and this is what I want you guys to do as well whenever you're doing the problems, you're going to want to do a table, kind of like how I have in step 1. I have x on the right hand side and I have y on the left hand side. I'm going to list all my x values. So here I'm going to write 7, right? Because that's my x value here. 8, because that's my next one. 9, right? You guys see the pattern, right? You guys see what I'm doing. 10. And if you notice, 10 is repeated, right? 10. I am going to write it again here, but that's for a specific reason. If when I ask you for the domain, you're not going to write it again. This is 11, and this is 12. Okay, so now we're going to do all the y values, which is the other number in the coordinate point. So here, for 7, its corresponding partner was 41. For the input of 8, my output is 45. For my input of 9, it's going to be 49. 10, it's going to be 52. Then it's 53. Then it's 55. Then it's 59. Okay, so I have my table of values. What do I do next? So now what I need you to do is you are going to graph this from, we have essentially coordinate points here. So here I have a very, very badly drawn graph. And you're going to have to draw your own graphs when you're doing your homework, okay? So here, we always want to start in the x-axis. Remember, the x-axis, this is your y-axis. Y is up and down. And the x is always from left to right. We always want to start here. And we're going to go to the right 7. So we're going to go 1, 2, 3, 4, 5, 6, 7. Start here. Now we're going to go up to 41. So we're going to kind of just guide it here. 41, it's about there. I'm going to go ahead and put a dot there. Okay, cool. That's the first one. Let's do the next one. 8, 45. So 8 and 45 is a little bit right there. So right next to it. 9, 49 would be the next one right below 50. 10, 52. 10, 52. Then we have 10 again, and it's 53, right above it. That's going to be a problem later, but we'll get to that later. 1155, right? 1155 and 1259. Now, I know this isn't the best looking graph. This is just kind of to give you an idea of what it should look like. The thing about this, right? Sorry, let me just make sure I got them all. The thing about this is you're trying to figure out if a relation is a function. And in order for us to determine if a relation is a function, what you need to do is you need to make sure that there can only be one x for every one y value, right? There is an exception to this, right? So let's go ahead and pair them up. So 7, 8, 9, 10. If you notice, 10 right here, I'm going to go ahead and delete the second 10 because I want you to see that this does this. Remember how I said we don't necessarily write it again? Well, we don't. I mean, I put it there because I wanted you guys to know that there was 2 coordinate points that use 10, which is why I originally had it there. But in reality, we don't really put it there. I'm doing this to pair them up so that you can see that every x is paired up with one y except for 10. And if you notice in the graph looks weird, right? Like instead of it being a straight line, it's a straight line and then it goes up, directly up, and then it does this. We're trying to see if this is a function, if this is an actual equation that can describe this, right? It looks weird. It's probably not going to be a function, right? So here, what's going on here is we have the same x twice, right? And they have multiple y's. One, remember the x is the input, right? And this is what we put into the equation, and this is what we get out of it. We can't put 10 inside of an equation, do some math with it, and then get 2 different answers, right? We just that isn't the case. Like let's say we have something like I don't know, x plus 5, right? And our x was 10. Well, if we replace x with 10, the answer is going to be 15. There's only one y. There's only one answer. We're not going to get 15 and 16. That's not the way it works. So what's going on, right? Here, let's put, for step 3, we're going to fill out what we call a mapping diagram, right? It's basically what I did in step 1, but step 3 is going to be organized in itself. You're going to see it and they're going to have things like this. And they're going to want you to draw arrows between them, right? And this is just to highlight the relationship we just put out, right? This 10 is the culprit here. This 10 went to 2 y's. Remember, this is your x and your y. We cannot have that. That's a big, like, we can't do that, all right? That x cannot be paired up with 2 different y's. Now, can the reverse be true? Can 2 different x's pair up with the same y? Yes. And you're going to see that right now. So remember, step 1, step 2, and step 3 are things that you guys are going to have to do, right? You guys are going to have to put things in a table, graph them, and then you're going to have to tell me whether all the x's correspond with at least one y, or if they don't, right? You're going to have to tell me if they're a relation or not. So the relation is a function. In this case, is this relation a function? No, it's not, because of this situation that's going on here. That x has 2 y's and that can't happen, right? Okay, if, however, that x was only paired up with either the 52 or the 53, and there was a different x that was paired up with the other one, then it would be a function. Okay, so what happens if you don't have numbers, right? What happens if they give you a graph and then they're like, okay, is this graph a function or not? And you're like, well, I don't have any numbers. How can I tell? Well, we're going to use something else called the vertical line test, right? I have it right there. These are 4 different examples, and we're going to use the vertical line test to determine if these lines are, these graphs are functions, right? You're basically doing what you did in the previous one, but this is just the kind of visual, right? The other one was numbers. This is more of a visual way of checking if something is a function or not, okay? So here in the first example, right, we have a straight line. For every x value, right? Remember, these are your x values. For every 1x, there's 1 y. Do you guys see that? Every single point has 1 unique x, and it has 1 unique y. So is this a function? Well, because there's only one, right? The vertical line test, what that basically means is we're going to draw a line that goes up and down on every x value. So you see how there's a dot there? Well, I drew a line, and if there can only be 1 dot per vertical line. So if there's only 1 dot per vertical line, it's a function, like right here, right? Why don't we move on to the next one? This is a parabola. It's not a straight line. We're trying to figure out if this is a function or not. Well, again, we're going to apply the vertical line test, right? And from this one, like let's say this is 1, we're going to draw a line from here, and we're going to go straight, right? Oops. And if this straight vertical line, if that dot is on it, it's supposed to be on it, guys, sorry. If that dot is on it, then that means there's only 1 x value for that vertical line. So currently that dot is passing the vertical line test, right? What about this one? Well, this one, there's no other dots, right? 3, 4. This one also passes. This one also passes, and this one also passes. I know that one's weird, but the point is every single dot is the only dot on that vertical line. So is this a function? Yes. Yes, it is. They both pass the vertical line test. But now we're going to go down here to the bottom ones, right? Let's do this 1, 2, and 3. 1, 2, and 3. Well, the first dot, right here, if we draw a line straight up, there's only one x for that one y. Remember, right? There's only one x for that. So that one single dot is okay. But look what happens for number 2, right? We have, there's a problem there. So that vertical line has two x's, right? Has two x's there that cross, has two y's that have the same x, right? And that's the problem. You can't have more than two dots for every single vertical line. So this automatically fails the vertical line test, right? And in case we needed more proof, this is a parabola, right? But it's on its side. 3 also fails the vertical line test. If any single line in a function fails the vertical line test, then it's not a function. So this is not a function, right? Okay, let's take a look at here. This is a little unusual. I have two of them on there, but they're both gonna fail the vertical line test. I just want to exaggerate just how much it is, like for this one, right? Right, there's two of these dots for this one single vertical line. So that means that this fails the vertical line test. This is a circle. You see how the circle, and they're all connected. So that means there's going to be 1 point above and 1 point below. This is also going to fail the vertical line test. So then this is, again, not a function. Okay. So for the top two are examples of a function that passed the vertical line test. Like, you don't really need numbers to figure that out. You can just look at it, look at where the dots are, and if there's only one dot for the vertical line, remember vertical means up and down, then those functions are going to be, those graphs are going to be functions. But the bottom two, there's two dots for every vertical line, right? That means that they're not functions, right? That means that I tried to put in one number, right? And then I got two different answers. And then that just doesn't make too much sense in terms of a graph. It makes sense in terms of other parts of math, but not this, okay? So takeaways from this video. Remember, a graph is a function if it passes the vertical line test, or if you figure this out mathematically or using numbers, right? It's okay to have the ones with the check marks or the ones that are okay. For example, the first one here, I'm talking about this one, the x, 1, 2, and 3. You see how the 1 and the 2 are two different x's, but they share the same value, right? If you notice, this situation is going on here, right? Where there's one single y has two x's, that's actually okay, right? Because what that's saying is, that's saying that two different inputs gave you the same answer at the end. And that's different from the other thing, right? Or ideally, we'd want every single x to be paired up with every single y, 1 to 1, right? That's this one that I'm talking about. Either of these situations means that they're functions, right? This is a function, that's a function. What isn't a function is this one right here, this one that's separated. Because the x, right, remember, what this is saying is that I put in 3 for the x, and my answer came out to a 7, and it also came out to an 8. That doesn't make any sense. It's not a function, and you need to be able to identify them as such. Okay, so once again, for this week's problems, we're going to have 1 through 22, or actually, let me see. Yeah, 1 through 22. I want to see all three parts. I want to see step 1, step 2, and step 3. on your, when you copy down the problems, make sure you do a table as step 1. Make sure you guys graph it to the best of your ability. Graph what the values of the table are. And step 3 is you're going to make a mapping diagram. For those of you who are unfamiliar with the term mapping diagram, it's step 3, it's this thing, right? It's basically, you can basically do it as step 1. You can do the lines on the graph, but when you're copying down the problems, I do want to see this because the problems are going to have what's it called, a mapping diagram there, and I want you to fill it out and draw the lines on your work. Make sure to show your work for that. Okay. In addition to that, for the problems that say that are just graphs, you can just write down, like, I think it's what, problem number like 10 or something, where they give you a graph, right? And they're just saying, is this a function? Or they're asking, does this pass the vertical line test? You can say yes, or you can say no, it does not. No, it does not pass the vertical line test, or yes, it does pass. Your answers can be, you can say like a single sentence. You don't necessarily have to copy over the graphs. I would encourage you to, just because I want you to be able to see them and practice graphing. But I understand if you just put those in there. Ultimately, you will have to know how to do that on the test. So just make sure you know what the vertical line test is. Okay, guys? All right. Good luck and look out for more instructions. Make sure you answer the daily questions and check in through Zoom at least once a week. If you're not checking in through Zoom, you're missing out on easy points, and they're eventually going to take a toll on your grade. Meaning that if you check in through no Zooms throughout the entire class, you're going to lose easily about 10% of your grade, which is entire letter grade. So easy points, guys. Just check in at least once a week through Zoom. The link is in the Google Classroom. All right, guys.